Yo, 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 yo. Gradius here, coming at you live. Here we go. It's a video for our transformations of the absolute value function. So what we're doing is we're taking the absolute value function, the parent function here, and we are going to transform it by moving it left and right, up and down, making it skinny, making it fat, stuff like that. Okay? So if you've not watched the video for just the absolute value function in general, I need you to go back and watch that one first. Very important that you watch that first, and then you can come and watch this video. So here we go. I have the absolute value function right here. F of x equals the absolute value of x. Quick reminder, absolute value function does make a v. And then that v is just going up 1 over 1 in both directions starting at 0, 0. This is what we call the parent function. This is the first function. And then what we're going to do is we're going to take this function and transform it in certain ways in order to, based on what numbers and values we have within our equation. So here I have the absolute value. Here's my parent function already graphed on here. What I want to do is I want to graph the absolute value of x minus 4 now. So this is something that we haven't seen yet. So what we're going to do to figure out how to graph it, we are going to make an xy table. Okay. So actually, let me fix this. We're going to make this the absolute value of x minus 4, and then out comes my f of x or my y. Okay. And sorry for this being so sloppy, but it's fine. Okay. So what we're going to do is we're going to use the points -2, -1, 0, 1, 2. So I'm going to plug these in. Absolute value of -2 minus 4. Absolute value of -2 is 2. 2 minus 4 is -2. The absolute value of -1 is +1 minus 4 is -3. The absolute value of 0 minus 4 is -4. The absolute value of 1 is 1, minus 4 is -3, and then the absolute value of 2 minus 4 is -2. So it looks like we have our axis of symmetry somewhere right around here, but let's look at and see what's happening here. So I have the point -2, -2, 1, 2, bam. -1, -3, 1, 2, 3. 0, -4, and then the right side is going to match it. So here I have a v. Again, looks like the v has the same slope because there's no multiplier in front, which we should know what that means by now. Okay, but what's happened is I've taken my vertex and I'm no longer at 0, 0. I've taken my vertex and I've shifted it down 1, 2, 3, 4. And that comes from this value of this -4 right here. Okay, so one way we can transform or translate our graph down or up, we take our vertex and we're translating it up and down by this value on the outside, the absolute value, saying plus or minus 4. Okay, so if this was a +4, then instead of shifting it down 4, I probably would have had to slide it 1, 2, 3, 4 up, and then I still have my up 1 over 1, like so. Okay, so we're going to write this down in official notes here in just a second, but I want to show you another example real quick. So what if I had the -4 inside my absolute value function? Okay, so what if it's on the inside? So what I'm going to do is, again, I'm going to make a table. I'm going to change my values just so it's something that is a little bit more, will help us see more. So instead of using -2 through 2 to show you what those do, I'm going to do, we're going to start at, let's start at +2. I'm just going to go 2, 3, 4, 5, 6. We're going to use these 5 values. Okay, so I'll use a different color. I'll keep it. So I have absolute value of x minus 4. So now that -4 is inside the absolute value function, so I'm going to have 2 minus 4. This is -2. The absolute value of -2 is +2. If I have 3 minus 4, this is -1. The absolute value of -1 is +1. 4 minus 4. The absolute value of 0 is 0. And I'm a little bit shifted off. Sorry, this should have gone here. Yeah, like that. For my 5, absolute value of 5 minus 4 is 1. And the absolute value of 6 minus 4 is 2. So now let's plot these points. So I have 2, 2. 1, 2 over 2. I then have 3, 1. That's right here. 4, 0. And then I have 5, 1, 6, 2. So I have the v still, but now it looks like what happened is I shifted my parent function to the right by 1, 2, 3, 4. So it shifted 4 to the right. I kept the exact same parent function. I translated it. I did a slide, took this point, slid it over 4 to the right. Took this point, slid it over 4 to the right. Took this point, 4 to the right, and so on and so forth. So we translated our absolute value function to the right 4. So inside these absolute value brackets, if we have a value, it's going to do a left and right shift. Now, if we notice, so this is -4, and on a graph, we normally think -4 is going to move me to the left, but it's a little bit weird, and we're going to go the exact opposite. Okay, so on the inside, it's going to make us go right if it's negative and left if it's positive, and we're going to get that down in official notes right here. So this is what I have. This is my absolute value function and all the possible values we could have. So I could have a value A here. Let's make sure we get this down. This is the slope of that V. Okay, so this is my slope. This is going to basically either compress it or it's going to make it a little bit wider. This H is my horizontal shift. And for those of you who are wondering, horizontal is left and right. And this K is my vertical shift. So I'm always going to have plus or minus something on the outside. That's going to tell me if I'm shifting my vertex up or down. The number on the inside is always going to shift my vertex left or right. And then from my vertex, I get to use my slope to create my V. So the vertex is always going to be the point -h. K. My axis of symmetry is always going to be the equation of x equals, and it's always going to be whatever that -h is. Okay? And this is going to work every single time. Okay? So it is a little different because in the formula, this is -h, which means it's always the opposite. That's why I put -hk for my x value. So we'll see what I mean by that in just a minute. But the biggest thing is that we realize that the inside is going to shift the horizontal left to right, and then the outside is going to give me a vertical shift up and down. So here's what we mean. So now I have an absolute value equation. I know it's absolute value because I have my absolute value function. And now I got to look at how my vertex is being shifted first. So we always start from the vertex, and then we worry about the compression on the outside, the slope. So I know I'm going to take my vertex. The parent function always starts at 0, 0, but I know now my vertex is being shifted up 3 because of this +3. So this is up 3. So 1, 2, 3. So it's going to be somewhere on y equals 3. Now I have to look at my horizontal shift. So because this is +1, we're going to do the opposite. So really my vertex, my x value is going to be the negative of this. So it's going to be -1. My y value, 3. So there's the vertex right here of this function. Is at -1, +3. I shifted to the left one because it's the opposite because of -h, and I shifted it up 3 because that's on the outside and that's my vertical shift. Now from here, I can actually use my slope of -2. Because it's negative, I know we're going to reflect it, and it's going to be facing down instead of up. And then I can go down 2 over 1. Down 2 over 1. Remember, it's a mirror image because this is my axis of symmetry right here. I'm just going to draw a dotted line so we can see that's where I basically place the mirror, and the left side should match the right side, just going in opposite directions. And I keep going down 2 over 1. I have an upside down V. It's been compressed a little bit, so it's a little skinnier than normal. There's my axis of symmetry. My axis of symmetry is at x equals -1. And I'm done. If I were asked for the range and the domain, okay, that's one that I didn't have on this slide. My domain is all the x values. Well, it's still all real numbers. That has not changed. Okay, because I'm still going forever to the left, which is all my x values, forever to the right, which is all my x values, positive x values. But my range has now changed. It's no longer just y is less than 0, or y is less than or equal to 0, or y is greater than or equal to 0. My range is now, if it's starting at y is 3, okay, but it's facing downward, so now it's going to be y is less than or equal to +3, because it can't be above 3. Okay, go ahead and try this one on your own, see how you do. Give me the domain, give me the range, and we'll see how you go. So start with the vertex. No tables necessary here. Do not make a table. Try to graph it without. Okay, so I just got to figure out what my vertex is to start. Okay, so my vertex, my x value is going to be the opposite of what's inside of here. So because it's -3, it's going to be +3, and then my y value is on the outside, -5. So there's my vertex, 1, 2, 3, 1, 2, 3, 4, 5. So I shifted it down 5 and over to the right 3. Now I get to use my slope of 1/2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, the opposite direction. And that's it. I have my v. It's a little bit wider because I have a slope of less than 1 but greater than 0. It's a fraction. Okay, facing upwards because it's positive, and then there's my vertical and horizontal shift. My domain is all real numbers, and my range is y is greater than or equal to -5 because my y's have to be bigger than -5. Okay, we also call this, my vertex can either be my minimum or my maximum value as well, depending on which way it's facing. So my minimum value for this one is -5, whereas my maximum value for this one would have been +3. And it doesn't have a minimum because it goes down forever, and this one doesn't have a maximum because it goes up forever. Okay. All right, last one. Give it a shot. Make sure we got this. This is super important that we get this down. So try it again. Pause it. No table. Go. All right, my vertex, again, we know it's -hk, so that means my vertex is going to be +1 because it's the opposite of the inside, and +3. 1, 1, 2, 3, bam. All right. Oh, I forgot a joke. We're going to stop there. How do you make 7 an even number? So how do you make the number 7 an even number? You just take out the s. If I have 7, I take out the s, even number. Ha ha! Tricky. All right, moving on. Now, so I have my vertex, and then now I got to use my slope from here. It's just negative. There's no number out there, which means it's really -1, which really means we're just reflecting it and opening it up downwards with a slope of -1. And that's going both ways. All right. There's my absolute value graph. My domain, all real numbers, because all the x values are included in this, but my range is just going to be y is less than or equal to 1, 2, 3. It's less than or equal to because it's facing downwards. That is all. Oh, and my axis of symmetry, if asked, just in case, is at the vertex, so that would be my axis of symmetry. I'll just put axis here, is x equals 1. That's the line of my axis of symmetry. Okay. That's it, guys. I hope this video helped. Let me know if you have any questions. Good luck. Gridius